So I told you guys two different ways to find the coefficients of for the binomial expansions, and I'm just going to record this sort of proof of why they both work. So I told you, for one thing, that you start out doing n choose n, and then you go n choose one fewer, and so forth until you get down to, and these are your coefficients. Then I also told you that you could go like this and then add these, add those, like that. So I just want to make an argument that that's the same. So first, let me just show you a few of them so that you believe. 0, choose 0. If I have nothing and I want to know how many ways I can choose nothing, it's the accept your fate way. There's only the one way. And then 1, choose 1. I, choose the 1. Or 1, choose 0. There's one way to choose nobody. Over here, 2, choose 2. There's one way to do that. But there are 2 ways to choose 1 out of 2. And then there's still just one way to choose nobody. If you have 3 people, there's one way to choose them all. There are 3 ways to choose 2 because you can unchoose any of the 3. And then, and then there's 3 ways to choose 1 person, which is choose one of the 3. And then 1 way to choose nobody. So you see that it's, had I written that 3 correctly, it'd be clear, but it's shaken out the same way. So here's the point. When you go, you add these 2, right? So I want to show basically why is it, let me go one level down so that we get 4, choose 4, 4, choose 3, 4, choose 2, 4, choose 1, and 4, choose 0. Why is it, for example, that 3, choose 2 plus 3, choose 1 is 4, choose 2? Why should this be? That's what I'm going to write a proof of, but with a kind of random n. I just want to note that the larger value here is the one that gets repeated. So in my proof, I'm going to have a k. That was weird. I'm going to have a k and a k plus 1. And then I'm going to have a k plus 1 over here, okay, because the larger value is the same. All right. On whatever level's on top, I'm going to have n, choose k, and then I go up 1, but I still have the same n, and I'm trying to show, forget that part, that this is equal to go a level down, so you have a bigger n, but that same larger k. So this is what I'm trying to show. All right. That up there so we can keep it. I'm going to start by writing out what these are by definition. So this is n factorial over k factorial times n minus k factorial. That's the definition of n choose k. So then over here, I still have n factorial, but now I have k plus 1 factorial and n minus k plus 1 factorial, which is I wish my chalk was doing better, but Okay, so that's these expanded, so that's distributing that minus sign. If I'm going to add two fractions, I need a common denominator. I have a k factorial here. Let me write this down first. I have a k factorial, and I need a k plus 1 factorial. K plus 1 times k factorial is k plus 1 factorial. So I'm going to write k plus 1 factorial. I'm going to have it as soon as I put a k plus 1 up here so that I'm not multiplying by anything but 1. So I've put k plus 1 over k plus 1. Maybe I should write that out. Okay, so I've got n factorial over k factorial n minus k factorial. And I'm going to multiply through times k plus 1 over k plus 1. And then for this one, I already have the k plus 1 factorial, so I'm all fine with that, but I need to have n minus k factorial. This starts one lower than n minus k, just like k is one lower than k plus 1, so I'm going to multiply by n minus k over n minus k. And the only reason that I fixed this one over here and this one over here is because this is the one that had more stuff. This was k plus 1 times k da 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 da, and this was k da 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 da. So this had an extra term, and this one has an extra term on the second part. Okay, so now that I have a common denominator, I need to kind of work out what it is. So I have n factorial times k plus 1 plus n factorial times n minus k over, so I built k plus 1 factorial, n minus k factorial. Remember, that was the goal. Okay. So this is, I'm going to factor out the n factorial on the top. The k's cancel, and I have n plus 1 times n factorial, which is n plus 1 factorial. You know that you want this to reference n plus 1, so I'm just going to kind of adjust the way it's written. We have k plus 1 factorial. I want it to have an n plus 1 running around, so I'm just going to go plus 1 minus 1 so that I haven't done anything at all, except make it look more like I want it to. Okay, now I know I want it to say n plus 1 minus something else, so I'm going to kind of factor out that minus sign. Which leaves me 1 plus k equals n plus 1 factorial over k plus 1 factorial n plus 1 minus k plus 1 factorial. This was our goal, remember? It's n plus 1, choose k plus 1, and that is the definition of that. So this is a proof. I'm sort of just playing with the definitions. It's like a bone knives and bearskins kind of way. If you have a way to think about it, which explains intuitively why choosing k people out of n and then choosing k plus 1 people out of n and adding those up would lead to choosing k plus 1 people out of n plus 1, then make me a little video of that and post it here. It may be that you can Google such an answer, but that is not fun, and that is not what I would like you to do. So